Good afternoon, this is Schweitzer, and this is a short little video looking at some of the pre-lab content for this particular lab called concentration of hydrogen peroxide. A few things I'm going to mention to you. There's another video here on physically setting the lab up and stuff. So I'm assuming you're going to realize, okay, we put our solution in here, and we have a little vial here, and it's in the video as well, and some safety concerns and steps and stuff like nature. But anyways, we're going to be attempting to find concentration, or really moles per liter of the hydrogen peroxide, this stuff right here. So making a long story short here, when we measure our volume of the hydrogen peroxide, that's really just this. I'm not going to give every single step away of this thing, but you should realize that that's the volume right there. So that should be measured carefully. Other things that happens, well, it decomposes. It produces O2. It also produces, I don't have on my picture here, but H2O. So two gases are produced pretty quickly here. Again, if you don't see something taking place, then there's something wrong. So let me know. But either way, when we produce all these gases, and the gases are produced relatively quickly, the main gases in here are the oxygen and the H2O gases that are going to come down through here and drive out all sorts of volume. This volume that drives out is equal to the water level that gets pushed into this container. And of course, people are always asking me what this volume looks for. Maybe the more videos I do, the less kids read, but the volume equals this displaced water of the oxygen gas and the H2O gas. So this is just a giant Pivner question. I need moles, and I'm going to get moles of right here, but these aren't necessarily the same moles. Okay? So if we look at what we have here, in this gas container, there's going to be some gases produced. And what would this sample look like? Well, notice we're getting a 2-to-1 ratio between these two gases. So regardless, I'm going to have H2O, H2O, and O2. And it's going to be in that proportion. So because of that, whatever my pressure is, total, is going to be proportional to my total moles, N total. So N total is equal to N of the O2 plus N of the H2O. All right, so that means my partial pressure is that of the O2 plus the partial pressure of the H2O. Now keep in mind, my main goal is to find the moles of this stuff. So long story short, I'm looking to get the moles of this. So I want the moles of one of these guys. And then let's just say moles of O2. Now the instructions, the questions in the back and the preliminary questions, I should say they say preliminary, but the second half of it is all based on your calculations. These solve for the O2, and then you can jump from the moles of O2 that you have to moles of this. And for every one of these, we get two of those, and that's N. So we're going to use our sample here, which is going to be PV over RT. And keep in mind, if you put the total pressure inside here, then you're going to get the total moles. If you put the partial pressure of just the O2 in there, you're going to get the moles of O2. And at that point, you can kick your moles of O2 over to moles of H2O2, and then of course you can kick that to grams of, well, we don't even need grams, never mind, moles of H2O2, and just plop that into there, and you'll have your, what you consider to be your molarity of your solution. Now these things, the solution decomposes quickly, and I think it's pretty common for me to have a kid complain about this reaction's not running because I grabbed a sample off the shelf and it was already decomposed. It decomposes relatively quickly. So 3% is kind of what they sell, but either way, I think that's probably about all that we're going to add into some of the preliminary calculations. I'll add a second video on the answers to the other questions. Thank you. Bye.